Yes.
Okay. Hello, my name is Omar. I'm again part 3 from the Hemostasis in the Hematology and Coag Lab. As you say, these the two pathways by which we can in vitro clot the blood. One is called the extrinsic pathways, and the other is called the intrinsic pathways. This is the extrinsic, and this is the intrinsic. The extrinsic pathways test or PT, the PT test, prothrombin time, test the clotting factor in the extrinsic pathway, while the PTT time or APTT time check for the clotting factor in the intrinsic pathway. Now, PTT stands for partial thromboplastin time or activated partial thromboplastin time. I'll tell you in a minute what the difference between them. Now, we did so far PT and PTT, the tilted tube test, and it's not very reliable, it's no longer done, but we did it to show you the actual clot, actually blood clots. Now, بالنسبة للبلاد, قلنا البلاد has to be very, very critical. Blood to sodium citrate ratio it has to be exactly this, exact ratio, which is 9 volume of blood, 1 volume of sodium citrate. So if you have a tube that has 0.5 milliliter sodium citrate, so the full tube has to draw 4.5 volume of blood. Or if the amount of sodium citrate 0.2, we draw 1.8 milliliter of blood. It tells you the volume of the blood. In this case here, we have a 2 milliliter tube. 2 milliliter tube. Up to here is 2 milliliter. You can see the sodium citrate here. It is 0.2 milliliter sodium citrate. So how much blood we take? This tube takes up to here with this 1.8 milliliter of blood. Now, before we do the test, we have to check for clotting. Even though we know there is anticoagulant here, should not clot. Occasionally, about 1 in 100 tubes, it clots. Even though if it says anticoagulant, it clots. If the clotted blood tube clotted, we see fibrin clot in the plasma or in the blood. We don't do the test. Why does it clot? Sometimes when the phlebotomist draw the tubes and put it directly in the bin, it does not. If you don't mix it properly, it will clot, and we know that from phlebotomy. Now we have to do all now automated PT and PTT. PT stands for prothrombin time, extrinsic pathway. What I mean by extrinsic pathway is the clotting factor in the extrinsic pathway. In this case here, we have plasma, and we add to it the reagent, which is tissue, thromboplastin plus calcium. In the PTT or APTT, and intrinsic pathway, and the tube here, we add the plasma, and we add to it the reagent was made of platelet, phospholipid, and calcium. Now, what's the difference between PTT and APTT? In the old days, my early days in this business, we only did PTT. We didn't do APTT. But a PTT, when we did the PTT, the normal range between 70 to 80 seconds. It's very high. So it takes a long time and it was not reliable. What they added to because the PTT, it took a long time to activate the clotting factor. So what they add to the reagent, in addition to platelet phospholipid and calcium, and add another compound called activator. تقول شو activator. لهالسبب it's called APTT, or activated partial thromboplastin time. So when we did APTT, so in addition to these two, we need to activator. Now, when we added the activators, the factors are activated faster in the extrinsic pathway. It's on a normal range between 25 to 35 seconds, instead between 80 to 70 to 80 seconds, and sometimes more. بالنسبة للPT, هذه PTT, not PTT, APTT. We don't, even when we say PTT, we mean APTT, because we are used to saying PTT. It's a PTT, APTT. But 11.5 to, or 11.0 to 12.5 second for normal range for PT. It depends on the labs. The normal range varies. The normal range varies. Now, sometimes when we do PT or PTT, we have to make sure that we don't take anything that might affect the test. For example, if somebody is on warfarin or Coumadin, is the same thing. It's called a thinner blood. People who really are prone to thrombosis, internal thrombosis, they give them what's called warfarin or Coumadins. These warfarin or Coumadins inhibit factor K, inhibit vitamin K, which affect PT, which affect what? PT, increase the PT. Now, we have to make sure, before we do PT, we have to make sure, ask the patient whether he's taking Coumadin or warfarin is the same, because it increases the PT. Now, بالنسبة للPTT or APTT, في عندنا another blood thinner or anticoagulant called heparin. Is a patient on heparin, it affects APTT. So I have to make sure the patient is not on heparin. Heparin affects APTT, while warfarin or Coumadins affect PT. Now, there is one thing that's very, 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 very important. If we have a short draw, يعني, this is the top blood tube, and this is what is supposed to draw up to here, 5 milli up to here. We should draw up to 5 milli up to here. Now, if we draw blood up to here, it's called short draw. Short what? What's going to happen here? Remember that originally, if in a 5 milliliter blue top, 5 milliliter what? Blue top, it has already what? 0.5 milliliter. milliliter sodium citrate. Now this sodium citrate is measured and designed to neutralize all the calcium in 4.5 milliliter, not in this much of blood, in this much of blood. So in this case, we will have excess sodium citrate. You have excess sodium citrate. So we draw it like this. this is called short draw. In this case, see the ratio of sodium citrate to the blood is not good. This is more excess sodium citrate. When we add calcium, when we do in PT, don't we add calcium? The calcium, instead of being utilized to clot, will be sucked in by the excess sodium citrate. We will have false positive. We'll have شو falsely high PT. Now, on the other hand too, some people, their blood look like this. Looks like this when we spin it. Or looks like this when you spin it. This is anemic. This is very low hematocrit. This is extremely high hematocrit. So this is how much plasma we have from here to here. A lot of شو plasma. Very small plasma. In this case, the ratio 9:1, it does not apply. The ratio of 1:1 is only applies to people who has normal crit or keef or tail. For people whose hematocrit less than 25% or over 55%, the 1:9 ratio does not apply, because these have excess plasma, a lot of calcium. Here have less plasma and very few of calcium. Either we'll have excess calcium here, or we have excess sodium citrate here. In this case, there is a formula in the book. We have to follow it, and we have to tell you and tell you exactly how much to add sodium citrate to 5 milliliter tube. So the formula is, it goes like this. Amount of sodium citrate يساوي 100 minus HCT crit times 0.5 over normal plasma volume, which is 60%. If we give you an example, someone has a hematocrit, a patient has a hematocrit 60%. Oh no, this is over 55. How much? This 4.5 milliliter doesn't apply. The amount in this case of sodium citrate needed is much less. Will be 100 minus 60 times 0.5 over 60 بيطلع 0.3 0.33 milliliter and not 0.5 milliliter. So in this case, if somebody has hematocrit of 60%, we apply this. So we put in the tube, instead of 0.5 milliliter, we put 0.33 milliliter sodium citrate, and we fill the rest with the blood the rest what? With the blood. Okay? And the same, you can have an example of somebody who has like hematocrit of 20%, well, you'll get more than 0.5. Now, a PT, if we're gonna do PT, normal range of PT on 11 to 13.5 in my book, and some references 11 to 12.5. It depends on the tissue thromboplastin we are using. Increase in case of cirrhosis of the liver, DIC, vitamin K deficiency, factor 7 deficiency, factor 10 deficiency, and factor 2 deficiencies. This is for PTT. For PTT, practically cirrhosis of the liver increases, DIC increases, factor 12 deficiency, factor 8 deficiency, and factor 9 deficiencies. Now, we are going to stop here, and we are going to go to, we do the automated test for a PT and PTT. I will show you how it's done. Thank you. And tomorrow or next week, we will try to finish the hemostasis. Thank you.